Hey everybody, welcome. Thanks for showing up for New Mexico Science Fiesta. My name's Kevin Dilley. I'm here at Explora Science Museum, and we're going to be looking at some fantastic flames today. So we're going to be doing some stuff with fire. That's right. So we want to make sure safety first. So I've got my safety goggles on. We've got a fire extinguisher at the ready, but hopefully we won't need that. But we're going to be doing stuff with fire. But before we get to the fire, actually, the first thing we need to do is we're going to look at some water. Okay, so we're going to start with water first because we are going to look at something called surface area. And you'll see why we're looking at water first in just a minute. So I've got here 2 graduated cylinders, so 2 tubes here, and I've got some Alka-Seltzer. So I don't know if you're familiar with Alka-Seltzer. Some folks might be, some folks might not. Basically, it's just this little tablet. So it's a white tablet, and I'm gonna put one of them into this graduated cylinder. The other one, so that one I left whole. This one I'm gonna ground up, and so we need to do that the fun way using a hammer. So we're just gonna pound on this, break it up. There we go. So we've got some smaller pieces now. Oh, that's not quite small enough yet. Let's make it a little bit smaller. We really want to ground it up. So we've just got a powder. And so this powder, I'm going to put into the other graduated cylinder. So I'm going to put that one in here, get that all in there. And we're going to see if there's a difference between these two things. Actually, let me ground this up just a little bit more. I want it to really be a powder so that you can really see what's happening here, okay? Get this ground up. All right. There, that's looking better. All right, so now we've got one that has the whole, the completely unbroken up Alka-Seltzer. The other one has the ground up Alka-Seltzer. And we're going to see what happens when we put some water in each of them. So I'm going to pour some water in here, about 50 milliliters or so, right about there. I'll put some in this one as well. Try and get about the same amount. But a little bit more in here. All right. So now, here we go. I've got, this one is whole, so it's not broken up. This one is all broken up, and I've got 2 containers of water. So we're going to pour them in at the same time. And let's see what happens. Remember, it's the same thing in each one, the same amount in each one, but let's see if they react the same. So we'll put them in, pour it in, and what do you guys notice happening? Anything happening? Notice in this one, bring it up a little bit closer, we've got more bubbles in this one, right? This one, there's some bubbles going on in there, but definitely not as much. And so what's happening here is something called surface area. So surface area is when we have a material. If we have just the whole material, it's just the outside, the surface of it, that reacts with something. In this case, the Alka-Seltzer reacts with the water, and it creates these bubbles. And so with the one that's whole, it just has that outer surface. But when we break it up into smaller pieces, there's a lot more outer surface area that the water can react to. And so we get a bigger reaction. We saw a lot more bubbles. And so this shows us that with surface area, the more surface area there is, there's more opportunities for reaction. And so why am I talking about this when I said I was going to be talking about fire and flames? Well, let's get to it right now. So we've got another thing here. I've got here something that is called Lycopodium. So Lycopodium, it's the spores from club moss. So take this plant, club moss, get the little spores from it. It's these tiny little, it's this little powder. And so if I take this powder, and I'm going to put some into this dish. I'll come up a little bit closer so that you can see it. I'll put a little bit into this dish, and we see that it's this interesting kind of yellowish powder. And I'm going to take some flame. Here's our first instance of some flame. And we'll see what happens when we try and light this on fire. So I'll put my flame here, and we see nothing's really happening, right? It's not bursting into flame. Nothing's really happening. I can smell it a little bit. Some of it was burning, so it definitely does burn, but nothing too exciting, right? So right now, this is kind of like that whole Alka-Seltzer tablet. It's got some surface area, but it's all clumped together. So what happens if we spread it out so that we can get the flame to be able to get more surface area, react with more surface area of the lycopodium powder? And to do that, we're going to aerosolize it. So we're going to spray it in the air and spread it out and see what happens if we do that. So to do that, I've got this little contraption. So it's just a tube and a lighter. And so I'm going to put some in here. I'll blow on the tube and spray the lycopodium powder out. And we'll see what happens when we do that. Okay, so I've got my lycopodium. I'm going to squirt some in here. Okay, so I've got some in my tube. Now I'm going to light this and then blow it. So we'll see what happens. So let's be good scientists out there. Let's make some observations. Let's see what happens when we do it. Okay, so here we go. Light the flame. Get ready. I'm going to blow 1, 2, 3. There we go. A little bit different reaction, wasn't it, right? So when I just put the flame to the lycopodium powder in the bowl here, nothing's really happening. But if we spread it out, if we make it so that there's a lot more surface area for the flame to react with, then we can get this big reaction, this fireball. And so this is definitely something fun and interesting to see, but it's also something that can be very dangerous. So we can see that just, a material like this that seems pretty harmless can be very dangerous. So if there's different powders and stuff that are flammable, and they get spread out so that there's a lot of air around it, there's a lot of oxygen, a lot of surface area to react with, then we can see that we can have these big flames. And that can be very dangerous. So for instance, grain silos where they store grains, sometimes that inside there you can get a lot of the grains to become aerosolized, to become spread out in the air. If there's a flame in there, we're going to have not just a fireball, but a big explosion. So that's why it's really important to be aware and careful with these types of things. And we can see why now, all because of surface area and spreading things out. So what we're going to do now, the next thing we're going to do is we're going to look at some other stuff with flames. So the next one we'll do is, let's look at a fire in a slightly different way. Actually, let's do this. So we've got here a water jug. Okay, it doesn't have any water in it. It's empty. But we're going to put something in there. We're going to put in here some alcohol. Okay, so we're going to use some methyl alcohol. And so I've got some here in this flask. I'm going to pour some in here, and let's see the same thing. So if I put some of this into, if I light this, we're going to get a flame coming off the alcohol. This is the type of alcohol you maybe use for a Bunsen burner, or maybe you'd use it in a camp stove, something like that. But we're going to put a little bit into our container here. So I'll pour some into my jug. And I'm going to swirl this around and spread it around. So I'm trying to coat all of the outside of my container here, and we are going to let it evaporate. So same thing. If we have it just whole and just as a liquid, we can light it and it'll light up. But what's going to happen if we spread it out and let it turn into a vapor? So I've got a bunch in here that's evaporated. So this is full of this alcohol vapor. It's turned into a gas. Let me pour off a little bit of the alcohol now. So we don't need all of it in there. We're just trying to coat the outside of our container. And now we're going to light it. And we're going to see how it's going to react in this container. So it's got some place for it to go, but let's see what happens when we do this. So again, let's make some observations. So if I could, I'd turn down the light so we could see it a lot better. But as it is, I think we'll see something. We also might hear something. Okay? So again, being safe. So I'm going to light this piece of wood and do it from a distance, so I'm not right next to it, because this is going to be big. So keep an eye on the container and also up above. Let's see what happens there. So let's light this wood. And all right, there we go. You guys ready? 1, 2, Pretty good, huh? Pretty loud, right? So this little experiment is called the Whoosh Bottle, for reasons that you might realize after seeing it and hearing it, right? So it creates this big whoosh. And so what's happening here? So we had our gas vapor in here, our alcohol vapor inside the container. There's some oxygen in there, and when we light it, same type of thing that's happening with our lycopodium powder. So it's vaporized. So there's all the surface area. There's oxygen there. There's the vapor. And so when we light it, it can fill up this whole thing with that fire. And it only has one place to go. It's expanding as the fire is being lit. And so it's going to come out of the container. So that movement of air, just like with musical instruments, wind instruments, right? We push air through a small opening, we create some sound. Same thing with this. We couldn't quite see what was happening inside the bottle because it was so bright out here, but inside you'll also see the flames kind of going up and along and back down the sides. It kind of wavers a little bit in here. So if you want to, you can look up the Whoosh Bottle later, and you might see some other videos of it so that you can see in the dark what's happening with the flames in here. But this is our little experiment. Want to do it one more time? Should we do it one more time? We'll do it one more. Okay. All right. So we'll do it one more time. This, again, another bottle, so that we can start anew. So the other one, we want to make sure it's dry inside, so no water in it, and because that'll dampen our flame. And so whenever we light it up, water is one of the byproducts of it. So we're going to get some condensation in there, so it makes it so you can't do it for a little while in the same bottle. It doesn't work quite as well. So we'll come with a new dry one, and let's do it one more time. So now you know what to expect for this. So let's do it. This, light one wood here. Let's light. There we go. All right, here we go. Ready? 1, 2, 3. There we go. So that one you might have seen the second little burst of it after it went up and then again. So let's do one more experiment. I think we have time for one more. We're going to make a fire tornado. That's right, you heard me, a fire tornado. And again, let's see if we can see this in this bright light. If we could do it in the dark, it would be a lot easier to see. So I've got here just a container, a fireproof container. We'll use our same alcohol that we had before, and we'll put a little bit in here. Okay. And now this is denatured alcohol. It's methyl alcohol, and it's a clean burning fuel. So it's actually not the best fuel to use this with. If I had lighter fluid or something like that might be better, because we would really want to see the flames. So denatured alcohol usually gives us a pretty clean burning flame. But let's see if we can see it in this light. So I'm going to light this, and there we go. It's pretty hard to see it on screen here. So it has a blue flame to it, and I've got a turntable here. So I have something that I can spin to be able to spin my flame. So my flame is right here. I don't know if you can see it. I'll stand right here with my black shirt in the background. Maybe it'll make it a little bit easier to see. And if I spin this, you can't really see too much going on with it. It's really hard to see it in this bright light. And so right now, actually, spinning it just on here, nothing's really happening to the flame. It's spinning a little bit. So what we need to do is actually create something around it. So I'm gonna put this out. So we've got our flame put out, and fire tornadoes are actually something that happens in nature. So it is something that right now with all the wildfires that are happening, sometimes fire tornadoes can happen with that. When the air around it is swirling, it comes up just like when you get dust devils with the dust that's spinning. Same thing with a flame, so we can get it to go up. So what we're going to do is we need to create a vortex around our flame. And so we're going to do that by using this metal trash can. Okay, so I've got a metal trash can here, and you'll notice that the sides of it, air can go into it. And so let's put our fuel in the middle here. Let's try and get this center so that it doesn't spin off axis when I start spinning it. Let's see if we can get a fire tornado going in here. So let's light this back up. And I don't know if you can see that in there. Let's see. We'll try and get a little bit of shade here. There's some blue flames there. And I'm going to start spinning it. And let's see if we flames to come up. Sometimes they'll come up about this high and even start to do it. So let's get this flame to go and get any of that. You can see that. I can see a nice tornado going right now. So what's happening is around the edges of it, we're creating a vortex. We're creating this swirl of air going around. And the trash can is helping to create that. It's spinning the air around, and you can see that funnel of flame, of blue flames. It's very faint in this bright light, but this funnel of flames that's going up. And so that is something that can be very dangerous for all of those wonderful firefighters battling those wildfires. But here we can see it's just amazing to be able to see how air and fire can work together to create this interesting effect. All right, let me put this out. Quite work? There we go. All right, so let's move this off to the side. Let's see, do I have a few more minutes? If so, I can do one more activity. Okay, I'll do one more, okay? We'll see if we have time for this. So, we've been playing with fire. We've been experimenting with it. And so now, let's look at how we can put fire out. So, I've got my candle here. Let me just light it up. And so with this, we could put it out like at every birthday party, right? Just kind of blow on it, and we could do that, but that's not as interesting. So let's do something a little bit different. Let's make an invisible fire extinguisher. So I'm going to need a few materials for that. I'm going to need a couple beakers. I need some vinegar. I need some baking soda. We're going to make our invisible fire extinguisher. So I'm going to put my fire extinguisher, right into this beaker. So there's nothing in there right now, you can see. And so if I pour it on there, nothing happens to my flame, right? So it doesn't put it out. There's nothing in there. So we're going to make some invisible fire extinguisher in this beaker. We'll put it in here, and we will put out the flame. So what we're going to do is we're just going to start with some baking soda. So baking soda and vinegar, when we mix them together, you might have experienced this or seen this. This is the kind of classic volcano experiment that folks have done. So I'll put a couple of spoonfuls of baking soda in here. I'm going to put in some vinegar. And as we do that, as they mix together, we're going to see all these bubbles. Now, inside of the bubbles, we are creating carbon dioxide. So carbon dioxide is a gas, and it is being made inside the bubbles. Here we go. So there we go. We're making our invisible fire extinguisher, which is the carbon dioxide. So it is, all those bubbles are popping. So inside here, we have carbon dioxide. It's an invisible gas, but it's there. It's heavier than air. And so it's sitting in there, which means that I can pour it from here into the other container. I'm going to pour, not pouring the liquid, just my invisible carbon dioxide fire extinguisher. So now it's in here, and I will pour it onto my flame and put it out. There we go. So our invisible fire extinguisher was carbon dioxide. So fire needs three things, basically. It needs a fuel. In this case, that's the wax that's here in my candle. It needs heat, and so it gets heat, you can feel it, and it needs oxygen. So oxygen is the gas that's all around us in the atmosphere, and if we can push away, if we can take the place of all that oxygen with another gas, in this case carbon dioxide, then it'll put the flame out, and that's what we just did here to make our invisible fire extinguisher. All right, so thank you guys. I hope you enjoyed it. I hope you've been enjoying Science Fiesta. I've been having a lot of fun with it. I'm glad that I got to share with you some of these cool activities, or I should say hot activities. And stay tuned. You'll be seeing some other fantastic things today from some of our other presenters here at the New Mexico Science Fiesta. All right. So I'm going to put my mask back on.
And I'm going to walk over here and join you, Kevin.
All right.
That was so exciting.
Oh, thank you. Thank you.
It was, lighting, it was a little bit hard, but we can still see it. So
Good.
Tell me why you chose these experiments today.
Well, I wanted to do some stuff that was wow and amazing. So we've been doing a lot of stuff here at Explora, activities, sharing with folks that they could do at home. But sometimes it's interesting to see some things that you can't do at home. And so I wanted to go big today. I wanted to make some interesting flame and fire related activities, so that's why I chose these ones. And I hope you guys enjoyed them.
Oh, yeah, and that's a good reason, because, yeah, we've been trying to make sure people at home can do these things with us, but these kind of.
These are ones I would not recommend doing at home. You can do the thing with the Alka-Seltzer, and if you have adult supervision, maybe with the baking soda and vinegar. But for the other ones, I would say do not try these at home. But you can see some folks like me and others do these for you.
Right. And so you work here at Explora.
Yes.
And what is something that you've been working on lately, or some things you've been working on that are exciting to you?
Well, I think it's really interesting with the current times. Normally we have folks come here to the museum. It's a big draw, our museum. Everything's hands-on, which is not the best thing for right now. So it's been great to try new things over the internet, share with folks activities that they can do at home, using just materials that they have around the house. And so I found that really exciting, trying to figure out things that folks could do at their home and work with them so that they can lead them through the steps that they need to be able to do that.
Right. I think I agree with you completely. We have looked at what we normally do and been able to innovate and create new ways to share it with everyone out there on the internet and help them do it at home. So that's really, it is an exciting time, even though we are in a strange time.
Yeah, definitely. It's nice. Sometimes these things are opportunities, like you said, to innovate and to be able to try things new and be able to reach folks that we weren't able to reach before. So, normally it was folks that came here and we would go out to schools. But, we can reach people in lots of other places that we normally aren't seeing and interacting with. And that's exciting.
Yeah.
That's great.
Well, thank you so much, Kevin, for your demonstrations, and thank you for everyone for watching us for this breakout session. We will be returning. I want you guys to go back to the main stage. You can find that link down below or on our New Mexico Science Fiesta webpage on the Explora site. And we will be having Air Force Research Laboratory is going to be doing some really big explosions. So join us in the next few minutes and we'll be transitioning to that. Thank you so much.
Thank you.